The latest version's a little better.
Yeah, how many of you evaluated before LabVIEW 2013 was when the big program? Okay, guys, you need to give it a try. It's much better. Who has evaluated JKI VI Tester? Who's still using it? Okay, very different response than in Austin. So in Austin, I had a lot of more people actually still using JKI VI Tester. Is anybody using it? What was that?
JKI was in the room.
JKI. Yes?
I don't think they could hear you in the other room.
They cannot hear me in the other room?
No, you're not going to
So his mic is not working then?
No.
Okay, hello? Oh. So I was not talking through the microphone. Now I can hear myself. You know, that's not going to be possible. You know that people say that I like to present because I like to hear my voice. I hate my voice. Anyway, anybody here uses a custom solution for unit testing? Okay, what do you use for unit testing?
Wrote my own system, very simple.
So, okay, he wrote his own system, very simple. Can you turn on your mic and tell us just the quick elevator pitch of what your system does?
Just designed a very simple unit test framework from LabVIEW.
Okay, and
it's, well...
It runs the VIs magically? Do you have to script it?
It does nothing magically. It just looks for a folder with a certain name.
Okay.
And it runs all the VIs in there.
Okay. So looks for a folder with a certain name and runs all the VIs in it. That's great. Okay. Anybody else?
Yeah, Linux again, custom. So what we're trying to do right now is building a Maven backend and using some of these Java tools to keep the versioning, to keep track of things, but then most of the LabVIEW stuff is custom made.
Okay.
We tried using the VI test stand, the
unit test framework.
We tried using the JKI testing thingy, but since they were all kind of targeted for the Windows platform, again, it became difficult, so we had to do some in-house stuff.
Okay, so Linux. All right, so is this presentation for you? If your requirement change in all your projects, then this presentation is for you. If you work on large projects, this presentation is for you. If your small projects, quick one-week projects, come back for more features, this presentation is for you. If your team has multiple developers with different levels of proficiency, if you believe in unit testing but never find the justification to do it, this is my favorite. I had the privilege of working with very experienced LabVIEW developers in several occasions, and I always get this thing, well, you know, Fabiola, unit testing, it's great theory, but who really does it? And I'm like, well, I do. So if you're working with me, you have to do unit testing. So if you're not doing unit testing, that's what you're doing. It might look cool, but you're basically playing with fire. You know, the guys, I don't always test my code, but when I do, it's in production. So if you're waiting to do your test until you're done, that's what you're doing. So you might feel like you are very cool. The other excuse I get is I have a very clear picture in my head of the entire architecture. In some of the projects that I worked on, the customer might change their mind like really close to the end, and I can assure them, oh, it's going to take me 5 hours to change it because it's just this small change here. If it weren't for my unit test, I wouldn't be able to find out that I'm breaking corner cases that are not directly related to my code, but by some reason can be affected. So what is unit testing? Unit is going to be the smallest testable part of your application, and then testing, just making sure that the unit behaves as expected. So in LabVIEW, a unit is going to be a VI or a class, and testing is basically for a given set of inputs. I'm going to verify that the outputs are equal to what I expect them to be. Very simple. And we all do this right now, right? We enter certain numbers in the inputs, we change the values, we check the indicators, and then we know that our VI works. All right, over there on the corner, that's my code reviewer that I was mentioning earlier. And that's the box that I actually have next to my computer, so he's not eating all the cables. And that's the position he takes when he's doing code reviews. But that's my cat. And then that's my friend's cat. But anyway, types of unit testing. So why did I put those two cats there? Any idea?
Black box.
What was that?
Black box.
Black box. And then the other one is? White box.
White box.
Yeah. So what does it mean, black box and white box testing? But why are they called that way?
Because in the black box testing, you don't know what's actually in the code.
Yeah, you don't care how the code was implemented. You just say, if I give this input, I'm expecting this output. Yes, correct. And then the white box testing, you actually need to know what's in the code. So here goes a little quiz question. If this is a sub-VI, how many, what's the minimum number of diagrams that I have here?
2.
Okay, I have some 2s, I have some 3s. Anybody with 1? No? Okay, how many people 2? Raise hands. How many people think 3? Okay, there's 3. There's the full block diagram, and then there's the 2 cases for the error case and the no error case. So this is again, it's something that's, yeah, a lot of people is like, what are you talking about?
But actually, you need only 2 test cases to test the whole code.
Yes, but when the code coverage is calculated, the whole diagram is calculated as one diagram, and then the 2 diagrams of the case structures are calculated separately. So if you're using unit test framework, that's how it calculates it. And that's why I said it was a trick question.
But isn't the whole diagram calculated simply twice in both test cases?
Yes,
yeah.
I agree with you. So I'm just pointing out some of the things that I've learned throughout the time that I've been helping other teams implement unit testing, and that's why I brought it up. Because that's something that confuses people when they're reading the coverage results from the unit test framework. Okay, so this is, like I said, I've heard, theory is great, but in real life, who has time to do unit testing? So I'm going to make the case. Now, if you've seen some of the presentations from NI, or if you're taking the formal course, or if you're a CPI, you've seen the table that shows, if you find an error during design, kind of like was mentioned before, it costs like $1 to fix it. If you find it during development, it costs $100. If you find it after release, it's $40,000, right? I found that whenever I present that slide to my customers or students when I'm teaching a class, the concept just goes completely over their head. Right? It's just numbers, right? It makes sense, but it doesn't affect me. So I'm going to use a sample case from one of my customers. So the requirement was very simple. They produce isotopes, and they have a lot number on the isotopes that have the form of month, day, year. They calculate and return the expiration date for that lot by adding 9 days of decay. I changed the number of days, so I know there's a lot of very smart people here. You cannot go guess which isotope I'm talking about, because I changed the number of days of decay.
It's not 9.
What was that?
So it's not 9.
It's not 9. Or it might be 9. I don't know. All lot numbers have to have a Thursday date. I don't know why, but this particular facility can only produce lots on Thursday. I don't know. So the solution from the certified LabVIEW architect developer that was giving these very simple VI. Okay, before I show the code, anybody wants to volunteer how you would have implemented it? Anybody? I'm just trying to see if you guys are awake. It's very easy. Or maybe not so easy. A scan from string, and then what? Cast it to timestamp, and you add 9 days. Okay. So it is a very simple VI. Well, this is what happens when people go unsupervised and try to reinvent the wheel. This is the code. I'm not going to zoom in. It's not my interest for you to figure out why this code worked for years and then stopped working. It's just that this was my reaction. They tried to reinvent the wheel and ended up with a flat tire. There's also a problem with this VI. This VI is buried down in the code, and yet it produces a dialog when there's an error, when the lot number is not a problem. And I see some people laughing because this is one of the things that we all did at one point when we started programming, right? And it makes it very difficult to test our code. And also, it causes problems where you're running things overnight and a pop-up like this comes up and should not do it. So well, at least they documented their code. There's some documents there where they actually, in the documents, you can see that they came back later and found out that they were not covering all the corner cases. So they tried to change the number of decades and change the logic so they could catch the end of a decade. All right. So the background, the code was created around 2008. It took about 2 hours to write. We're guessing this because the guy is no longer working with them. And we assume that it also included some testing with a couple of known lot dates. It worked well until January of 2013, or to be more specific, they didn't realize there was a problem until January 2013. By then, the original developer was gone. It took about 5 hours to find that other problems in a different area of the code were actually related to this VI. They had to call the LabVIEW consultant to troubleshoot and fix. They had to stop production for 1 day. The client was very upset, and in this case, it's not my customer, the client, it's the end client, the hospital or facility that was getting the isotope were the ones that found out about the problem. This is a regulated environment. So cost analysis. VI development cost, let's say $200. Finding the bug on 2013, troubleshooting time, let's say $500. 1 day production stop, more than $10,000. The site has revenues of around $100 million a year. This is a huge problem. Incorrect expiration date, end customer found out and complained. This is a regulated industry, so this means that they had to file a corrective and preventive action incident. They had to have meetings to investigate and plan a corrective action. They had to make sure that the state and federal regulators did not find out, because if they find out, they could flag these as a cause for further investigation, and the site could get closed, right? It's just, most of you, probably your applications are not that risky, but I just wanted to bring to your attention that if we compare this to the cost of VI development plus unit test, then we just go up to 500, right? So we should do unit tests not to get a check mark on a process checklist or just because we want to use a cool tool. We should just do it because it's right. And it saves money and time in the long run. So it is the right thing to do. Yes, go ahead.
So tell me if you're going to answer this later. But I'd be curious to know how you and other people in the room that do unit testing define which subset of
I'm
your
going to
VIs.
talk about it.
You're going to talk about that?
Yeah, because the next thing is, okay, so that was one VI in the project. That's the VI hierarchy window. How many of you have actually seen the VI hierarchy windows on your projects? Yeah, so I expanded it, and I went to the menu, and I said fit to window. So even though it is a very tiny VI over there, it was done in 2008. The program has had continuous developments. I can imagine some of the code you work on, Odd, that probably some of those very little dots there, those pixels, were done 10 years ago, right? Okay. So this is the solution I came up with. Again, I don't care about doing code review here. We can do it later. It might not have been the best thing. One of my friends said after the CLA Summit in Austin that that was probably a good use for units because I could have casted to seconds and then just add 9 days. But anyway, in general, at least it's cleaner to read, and it shows it returns an error at the bottom instead of a pop-up. So, Eli, are you telling me I need to test every VI on my system? No. You would end up with the size of the system would be like 3 times the size that I just showed. So here's my recommendation to my customers. In an ideal world, you would plan ahead to test, and you would test critical code and complex algorithms. So if you're working with the previous presenter, during the design time, you would decide which ones VIs would be tested like this. Now, do you guys think that that lot number check was a critical VI or a complex algorithm? No. My customer would have never spotted that VI to be tested during design phase. So my suggestion is like, yes, great, do that. Make sure that the heart of your system is tested. I worked with a customer that was doing a heart rate regulator. So we had an algorithm to find the systolic and diastolic pressure. In that case, the algorithm was the heart of the application. We needed to make sure that we could detect arrhythmias correctly, right? So we did unit testing the hell out of that VI. Now, if that fails, here's my suggestion. Add unit tests as project progresses. And do it for bugs found that could have been caught via unit test, and regression test to verify that new method returns the same results as an old method. Go ahead.
So a minor point from LabVIEW R&D. We had a similar general rule of thumb for many years. You add unit tests for critical code and complex algorithms. Starting sometime about 2 years ago and moving into the future, we've begun moving to every function gets unit tests.
Yeah.
And that,
do you use unit test framework?
Well, we're talking the C++, C#, and G all together. And no, we don't use unit test framework because we have one that we rolled before unit test framework existed, which we're not willing to port all of the existing code base from. But if we had unit test framework from the outset, almost certainly. But we've come to the conclusion that there's not much in our code that we can consider non-critical.
Yeah.
And so it depends on where you end up in the code stack. But whereas LabVIEW was much more of a top-level application layer and much more of a lab type of utility, it's moved down so far into the software stack for a lot of programs that we've come to the conclusion that you really can't make that judgment. So it may depend when you're developing your code on where you sit in the software stack and where you sit in your organization.
Eli?
When I work with customers, I often see it as a direct byproduct of the risk assessment. So
Yes.
if you're in a regulated industry, that's going to tell you where you have to spend your time and money
So
doing your work.
what I've seen, and one of the customers that I'm working with right now, they finished the prototype. They have the funding from the venture capitalists. They're going to move into FDA approval. And now they're coming back to check the checkboxes. So now we're going back after the whole thing is done, trying to identify what can be unit test.
That's really easy. It's risky because the program, quote unquote, works, right? So you can just write unit tests to demonstrate it works.
Yeah, exactly. And the problem is that when I was telling my customer, no, you should be doing as you go, his response was, well, but if I have them, now I have to run them every time. And the FDA is going to, assess me with that. And I'm like, exactly. But it's because it's not, again, he's doing it from the process, I want to add a check mark. He's not doing from the process, this is going to help me cover my butt when I make a change later on. I think there was Steve?
I would add to your plan ahead to test dates, to be quite honest with you, because if you look at where likely bugs appear, it's usually array manipulation, complex logic, complex algorithms, and dates.
Dates, yeah.
If you do a large database application, for example, dates are a pain in the neck.
Yeah. So I should probably add a date, and then my use case would have fell in there. Anyone else?
Add APIs to the list.
Yeah.
Yes. Does it make sense to follow a top-down approach if you have a look at the project hierarchy? If you begin at the top level and you begin unit tests at this top level and go down if it doesn't work?
That's considered integration testing. And the problem with the higher level you go is that you run the risk of not testing every single corner case. So for example, these people run a couple of tests and they had it passing, but they never run a test for the next 20 years, right? Yeah. So, okay. So steps to develop a simple VI. Normally what we do is we select our controls, we put our indicators, we write the VI code, we enter a value on the input, we verify that we run the VI, we verify that the output is correct, we move on, right? That's the typical, yeah, I did my unit test. I verified that whatever value I put in there just works. Now, when we're developing a complex VI, we do the same as before, but now we compare multiple inputs because it's a little bit more complex. Now, one thing that I see people do is, and I do it myself, is we get a blank block diagram, we add our code, we put a for loop so we can test different things, we run it, and then we're comfortable with it. Okay. Do you guys keep these test VIs? Yes. Do you ever run them again? Yes. So do you run them manually? No? Okay, so how do you guys run it? Testing. Okay, that's the one that I missed asking. So who uses testing for unit testing? See, that's why I forgot to ask it. Somebody else here also uses testing for unit testing? Yeah. So what's your experience, guys, on that?
It works.
So I did a search to see, because I was expecting a lot more people using it, and I found that Viewpoint Systems had an article in 2009 about using testing for unit testing.
We are using testing for many different things, so for us it was quite natural to just use it for another test, like a unit test framework, or we do also higher level tests with testing. So
yeah.
Also.
So one of the things that one of the guys from Austin told me is that it's also useful because normally when you go to production, it's a subset of your R&D test. So you can choose some of those tests that you were doing during R&D and then just migrate them, and they can be done in production as well. So over there, what's your experience with testing?
Well, actually, we use the test-stand file, and I have a LabVIEW administrator that parses it. Because I won't be able to compile the entire test system to run it on multiple platforms and see that the code runs on every type of executable, and because we develop a toolkit.
So the test and code gets built into the executable?
Now, actually, I did this with test and 2.
Okay.
And then I would like to transfer to other platforms, and Testing is only Windows. Unit Framework is only Windows as well.
Unit Test Framework can be in real time too.
Yeah, but only Windows, not Linux and Mac.
That's Eli's question.
It officially is only released for Windows right now, but it's an entirely G-based tool, and I've spoken with the R&D team about it. Basically, if you had to have it for another platform, it's doable, and just come talk to me.
Okay.
Yeah, but we've been doing this for 5-10 years, so that's why.
This is Stephen. I explicitly talked to the test stand team about this question before the CLA Summit for other reasons. They themselves say that they believe that if you already have test stand, it is an effective but not ideal solution for unit testing. They do much better job with testing of systems, and will point you in the direction of both VI Tester or Unit Test Framework for actual unit testing. But if it is part of a much larger test suite that you actually need to do in production, they think they have value there. Yeah. So if you already have it, it's worth looking at, but not as a first solution.
Okay. So test-driven development. So what if instead of writing the code to meet the requirements, you would write the test for the requirements first? Then you will write the code, and then you verify if the VI meets the requirements. Has anybody done this? Yeah, Agile, right? Yes. So it's part of Agile development. So the advantages is that it leads to cohesive VIs and less coupling. You run less the risk of trying to add embellishments to your code because you really want it to meet the requirements that you were set to meet. The developer focuses on meeting on those requirements, and there's less opportunity to add extra code that is not originally in the requirements.
Just a little aside, it's often of value to have the person who writes the unit test be a different person that writes the code.
Yes.
Otherwise, the person that writes the code will write it to satisfy just the unit test.
Yes, exactly.
And from our experience, this usually leads to much better requirements.
Yes, exactly, because it's when you start saying, okay, when I put a 2 here, you want this to turn green. Okay, what happens if I do a -2? Oh, I hadn't thought about that. And it leads to asking more questions from the customer. I totally agree with that. And it is really nice just to be able to run the code and say, look, this is the test that we agreed on, and it meets those requirements. So this is my little guy here. I had a customer where, I think I mentioned it before, where we did the whole toolkit, we did the whole application, and we had done the DLL using LabVIEW. When the time came for them to show it to their focus group of C developers that were going to be using the technology, they said, we don't want it. Why not? Because it's written in LabVIEW. So that's what I mentioned this morning, as my customer said, we know if we put you in front of them, you're going to convince them, but we cannot put you in front of every customer we have. So we need to have the DLL in C. So I looked for a friend of mine who is bilingual. He is fluent in LabVIEW and on C. He's a CLA, and he also is very proficient in C. And he did a driver developed in C for doing the DLL. Now, because he is fluent in LabVIEW, I told him, here are my unit tests. Your DLL, when it's wrapped in DLL calls in LabVIEW, needs to pass my unit tests. So if your code can pass my unit tests, you're done. So my customer was, one of the feedbacks that I got was like, we thought it was going to take you months to do the porting, right? And it would have, because my friend would come back always with, oh, you know, but we could add and remove. And I was like, no, you have to pass these unit tests. The only thing that I let him do was remove some of the unit tests that were testing private communication that should not have been exposed in the C code. And I was okay with that because some of the other tests would cover testing those functions. But for the most part I just gave him the unit test, gave him the original LabVIEW code, and just said, you do the same thing in C, you give me a DLL, you pass the unit test.
So did he just write a little C wrapper for your LabVIEW code?
No. Tools to facilitate unit testing. So we already talked about two. There's the National Instruments Unit Test Framework. It's preferred in regulatory environments. It reports percentage coverage, and it also is produced by NI, who is an ISO certified company. So that means that you don't have to validate the validator, right? So if you, depending on which type of environment you're working at, you need to say, well, if you're going to be using the unit test framework, you can say, well, it was developed by an ISO company. I'm not going to guarantee or try to validate that the tool works. Just like you don't go validating that the adding and the subtracting and the multiplication that comes in the primitive palettes work, right? You just assume those work. The JKI VI Tester, it helps you develop a test harness. It's good for testing classes. You can test dynamic dispatch of VIs without wrappers. On the unit test framework, you need wrappers if you're testing dynamic dispatch. And you can inherit from test and override setup and tear down methods. So what that means is if you have a hierarchy of classes, you can also have a hierarchy of tests that override the test depending on which child you're testing. Does that make sense?
Sorry, I encourage you to hassle me during my presentation tomorrow, but I was just going to comment. The code coverage report that the unit test framework includes, it's actually just calling G methods. They're private invoke nodes, so if you really want that and using testing or the VI tester, you can actually still obtain it.
On the JKI VI Tester, yeah. But
yeah, you just have to know how to.
But you would have to add it.
It's a super secret INI key, add it, and it's in there.
Okay.
Yeah.
So we should tell Jim to add it.
Just a little bit of a pitch here. So because I do so much work with classes, I prefer the VI tester from JKI over the unit test framework. But it's not because of deficiency in the unit test framework. These two test harnesses have a kind of opposing philosophies for how you go about writing unit tests. And this is a split in philosophy that is reflected a lot across lots of unit test tools around the world. And these two philosophies, one is a little bit closer to white box and one is a little closer to black box. And how you preserve your tests and the rules for it lead to different requirements for your testing strategies. And so you may actually find that depending on what you're doing, that you may find that the two tools are somewhat complementary. Now, I have not, and I don't think I would recommend that you adopt both tools for a single project, but you may find that you want to have both tools at hand depending on which project you're working on, because they do have a very different bend. If I was building a mathematics toolkit, I would want the unit test framework hands down. The way that it handles data and such is very different. So just throwing that out there.
So I prepared some demos. Most of you have already evaluated these things or saw them at presentations at NI, so I'm not going to let you see the whole thing. But what I'm doing there is taking the VI that I showed you earlier, right-click, new test, and then that creates a file with an LV test extension. Oops, went too far. And basically what it does, it opens this new window. So that's the new version of the the unit test framework for those of you that stopped evaluating it before 2013. It looks much better now. You have an icon of the VI, so you actually see which ones are your inputs and your outputs. And you can enter the different values that you want to test. So here's an example of where I'm entering the lot number, and then I'm going to put the expiration date. Now you can imagine this could have been done without actually having implemented the code on the background. I could just go enter the values for the lot number for the expiration date, and then I am going to go to this little button over here that's going to let me import the values from the VI, right? So when I press that import values from VI, it's going to populate the different values on the input value and on the expected value as well. And now I'm going to run this VI, this test, I mean, and the test is actually going to run the VI. So you probably didn't see that it actually ran the VI, so I'm going to go to Edit, and then reinitialize values to default, and now I'm going to run the test, and the test populates the input and verifies that the output is what I was expecting. So very simple. If I want to add a new test case now, let's say, for example, for an error, I'm just going to add one date to the date, and that's going to be no longer a Thursday, so I know I'm going to get an error. And in this case, I know that it's error 5000, and I really don't care about the expiration date, so we're just going to reinitialize that to default. And we are going to import the values again, and it's going to populate everything. Now, one of the things that you're going to notice here is that I don't care really about the status and the text because I didn't enter that. So my test is going to fail because I am comparing the actual string that I get back with an empty string, right? That's what I'm showing around here. The expected value was empty because I didn't enter anything. And that's why my test is failing. So there are different things that I can do here. And let me show you before I exit on the demo. The easiest thing that I could have done is go directly here on the comparison. And instead of doing an equal, I would have done by element. But I'm trying to show you kind of like my discovery path when I started using unit test framework. And my discovery path was that on the top, the error cluster has 3 checkboxes, right? So I couldn't find the 3 checkboxes on the bottom. So I went through the complicated path of actually closing the VI, the LV test, sorry, and open it in Notepad. And which is actually, this is really great because this means I can give a C developer or somebody else can in Excel create the definition for my test. This is published by NI, what is included in this file. So you can include everything that's in this file. It gives you, you can also add requirements IDs if you're using requirements gateway. And then the test cases that we just defined are listed on the bottom. And like I said, you can open this in Excel. And one thing you're going to find there is for test case number 2 is that I have a check for the source code and the number. So I'm going to change that to ignore now. And by changing that to ignore, once I save it and I open it in LabVIEW, on the unit test framework, it's actually going to show up the checkboxes. So again, I definitely went to the really treacherous path of doing it, but it's showing there and it's on check. I wanted to do this again for the discovery route to just show you what happened. And again, if I had shown by elements since the beginning, my checkboxes would have shown there. But I also wanted to show you the fact that it's just a text file, right? So you can have others define the tests for you, and they don't even need to be LabVIEW programmers. Okay? All right, so that's just showing the test results. The next thing I was going to show you here is the code coverage. So again, the code coverage is determined by, in this case, you would have the outer block diagram, the inner block diagram, and the 2 cases in it. So you would have the pink, the CN, and the white would be considered code covered. So when you go back to the code coverage report, which I am going to show now, you see that that's why I have 60% coverage, because it's 1, 2, 3 out of 5. So 3 out of 5 is 60%. Okay? Go ahead, Eli. What?
Are you going to talk about cyclomatic complexity at all?
Maybe, if we have time, because I'm really running behind.
It's a good proxy for testability of code.
Yeah.
That's why I throw it out there.
Yeah. All right. So anyway, the other thing I was going to show is if you label your case structures, which I think it's a good practice, you can actually see here on the uncovered diagrams it gives you the name you gave to your case structure. So in this case, my case structure 1 didn't have name, so it was the error case structure. And the other one had the name lot day needs to be on a Thursday. And then it's just basically showing that that test case is not covering the default case. So you actually get a report of which test case is not being covered on your case. All right, so that's the unit test framework. Now let's go to the next one. So this is VI Tester. Any questions?
Does code coverage only consider if you enter a block diagram
Yes.
or not? It does not consider code paths or input-output ranges?
So we're going to get to input-output ranges. I know that was one of your questions, and I'm going to get to it. I should get to it. So
code paths is sufficient. It is what you just asked. The case structures are equivalent to code paths. What it doesn't consider as ranges.
Yeah.
Unless you teach it.
Yeah. All right. Yeah. So I'm going to show that. So let me now show how it works on the VI tester, the JKI VI tester. Now this one requires a little bit more menu working. You have to create a class. So you go through the menu, you say new class. You're going to create a new class with the name of the test that you're going to be using, and it's going to create magically everything you need. So let me just fast forward. I'm going to give you links to these videos so you can see them later. So you end up with your class here. By the way, when you see the videos, I say tear down instead of tear down because it's spelled tear. So I was reading, and I know there's a lot more people here that would understand me than in Austin. Anyway, so it comes with a little VI template that you can use to change your unit under test. And what I'm doing there is just creating a new VI from the template, and that provides the tester. Now, when I go to the, well, I'm going to change there the icon just because I was being a little bit extra thorough there. If you go to the block diagram, it comes with a unit under test dummy that's supposed to return a cat. And what we're going to do is, using Quick Drop, because I have my project open, I just start typing the name of the VI that I want to test, which in our case is get the expiration date. And then I do the whole programming of the test. Now, here you can see that because we're using code to test code, you can make mistakes while you're creating the code to test the code. Right? It goes back to what I was saying, who's validating the validator. But you could have also made mistakes on entering the values on the unit test framework. So it's definitely not foolproof, but at least it gives you a different way of viewing, taking a look at your code.
That point there is the heart and soul of the that point there is the heart and soul of the philosophy difference between the unit test framework and the VI tester, is minimizing the amount of frameworks that you set up around your tests.
Yeah. Now, the one thing is, if you notice on both examples, it had the tool installed. So when I needed to create a unit test, I just had to create it. And the nice thing is that now I can run it. So I'm just going to the menu, say run unit test, I run it, it returns a report. So both of them are exercising the VI under test and providing inputs and outputs. Okay? Any questions? No? Okay. Okay.
I just wondered if you tried automating any of these frameworks.
Did I what?
Automate them? Run them on a scheduled task like every
Yes,
Friday?
both of them have APIs, so you can actually programmatically run them, both of them.
Okay, but do they integrate into other environments, like if you're having C++, Java code, and other things that you want to schedule at the same time or test at the same time?
I know that I've had a customer that has integrated with their continuous integration server, and they're using Jenkins, and I could ask them how they're doing it, but I know I had a customer that had that.
Right.
But they definitely use the API to make it
Yeah,
hook.
we could be interested in learning more about that.
Yeah. So. All right. So anyway, so that was that. Let me go to the next one. Okay. So what if lot number is part of a class? So now you need to actually do a set of VI, the VI under test, and a teardown. So if you, the way you would do it normally in LabVIEW is you would create. In this case, I'm just showing that the lot number and the expiration date are part of the private data of our class. And now what I'm going to show is just that I just replace, instead of having an input and an output. And we could debate if this is good code programming practice or not. I just figured it would be easier to stay with the same example and decide to put the lot number and date as part of the member of the classes. Of course, that means that now I cannot just go and enter values on the controls and run the VI and figure out what the inputs are. So that's when we start dragging VIs. And yes, my VIs don't have icons. I was pressed to get this running. So we're just setting one, and then basically what I'm going to end up doing is, with the magic of the cooking show here, is getting the different VIs on a row, my little train there, and do the whole equal, right, to figure out if both values are equal or not. Now, and then I just run it and make sure that it passes. So this is the typical VI that we create to do a quick and dirty test that a lot of people just throw away or save in a file that's called testing and they never run it again. I was really glad to see that a lot of you actually run it. Now, one of the things that I want you to see is that the 3 VIs that I have there are the VIs that I'm going to use now for the definition of the test on the unit test framework. So I'm going to go to the setup and tear down menu here on the top, and that's going to let me select which VIs. And basically, you don't realize this when you're configuring the test, but you're actually wiring. You're selecting which one is your setup VI, you're selecting which one is your teardown VI, and then you manually, with drop-down boxes, tell it which input is connected to which input. So you are wiring by text, basically, the way I see it. And we're basically translating that same VI that we just did, but using these connections with text. And this can also be, it's part of the definition of that text file that I showed you earlier, so this could be done programmatically. And now for the test cases, I just have to put what is my input for the setup, and then what is my, I don't care about the class, I just care about the actual lot number. So I'm going to put the same lot number that we have been using, and I'm just going to forward this so you see the thing filling up, right? But the main thing is, even though it doesn't look like you are wiring, it's actually you are wiring the setup, your unit under test, and the teardown, and you do the same thing, you set your values, right? Okay, so how would you do this with the JKI VI tester? Any volunteers? You're all asleep? You want to go? You're done? All right, let me show you that. What was that?
Before you go on, I'd be interested. This is kind of a functional test. You have one input and you have an output. Maybe more inputs and more outputs. What are you doing with internal states, with history inside the VI?
So that's more integration testing. So once
that's something else.
Yes. Now, yeah. So
okay.
I use some of these tools where I'm really kind of like blurring the line. Like I even had a driver where I actually tested the communication, the serial communication, and all the VIs that were doing the parser using the JKI VI tester, which is kind of already blurring the line with integration testing. But it made it really easy because I already had all the tests for the parser.
It's a common template for us. We have a lot of VIs that are running in their own while loop. So
yeah, so you have to do a little bit. You have to do a more complex tester. Now, one of the things that I do with those VIs that are loops is they have an API. They have a way other VIs or their modules are communicating with them. Yeah. Either because they're enqueuing things or they're sending messages via user events. So what you would be testing is, if I send this message, do I get the message back? So it goes back to Eli's point. You're testing the API at that point. You cannot test every single path of that.
But you cannot set up a test in that unit test framework.
You would have to use the JKI VI tester.
Okay.
Now, or your own, like Rolf was saying, your own thing where you have a VI, a folder that has certain name and you look up for it. All right, so now to Steen's question about, oops, I skipped one. No, I'm good. So the JKI VI tester, you probably already imagine what we end up with is we make that the private data of the test is the load class itself, and then we just that's the setup, and then on the actual test example, we end up with our lovely train of VIs replacing the unit under test, and we get the 3 VIs directly there. Okay, I could have chosen to put the lot number, setting the lot number inside the setup, but these would permit me to use the same setup for multiple test cases, and then on the different test cases, enter the numbers. All right, so one of the questions that Steen had was, what if you want to test ranges? With the JKI VI tester, it's really easy. You just put a for loop, right? And you just give it all your inputs. For the unit test framework, okay, what you have to do is you have to create test vectors. Now, this was something that it is on the help, but it was not evident to me because I kept trying to define the vector directly on the test definition. Turns out that we have a different type of file that is called the LVect. So what I'm going to do is I'm going to create a VI first that is just generating my array. I'm using LabVIEW just because I'm comfortable with LabVIEW, but we could have generated this with Excel, okay, and read it from Excel. Or we could have had someone else generate it in C. And I'm just generating 30 values. So I'm going to right-click on the unit test, and I'm selecting this guy on the bottom that said test vector. That creates a file called LVVect, okay? So my main thing here, Eli, is that I actually had to go to a different place to create my vector, and I don't have a way to create a new vector from the test definition because I wanted to click it there. So what you do here is you basically say, okay, I want to create a vector. I give it a name. I tell it from which file I'm getting it from. And I just set the names of the 2 vectors that I'm going to use. In this case, I'm clicking the import button, and it's showing me all the open VIs that I have at that moment. So I'm just going to say, okay, pick the one that I just created that generates the test vector, and populate the array with those values. So that populates automatically the vector. Now in this case, it's a one-to-one, so it's not very interesting. But let me pause it. So one of the advantages of doing this when you have multiple inputs is that the unit test framework, one of the things that it does that I think is really cool, is that you can make it match each one of your values with every single value on the second vector. So if you have very complex VIs where you want to test all the combinations possible of 2 inputs, the unit test framework takes care of that for you. So that's a way of doing it. I'm not going to show that, but if you guys are interested, we can do it on Thursday. But basically, it's just grabbing. Right now, it's just a one-to-one relationship. I'm just making sure that all my inputs are correct. I save the vector, and now I go to a different user interface, back to the test, and I have to define there, I'm saving it. So I'm going to go back to the original place where we were defining our LV test, and I'm going to go to the tear down, and then, well, this one I was still verifying that the previous code still works, so let me go to the test vectors. Okay, so it's back a little bit. There. So what I did there is just say, okay, I want to use that test vector. I point to that file that we just created, and then I just tell it which inputs I want to use. So if I had my way, I would have, instead of just the add remove, I would also have an extra button there that would be called new test vector that would open the test vector, because my path to discovery would have been a lot faster, and I would probably had started using unit test framework a lot sooner than I did, because I was like, oh, there's something there, but I don't know how to do it.
Fab. If I could just, I agree that there should be a new one there, but I wanted to make it clear that test vectors don't necessarily have to be tied to particular test cases.
Oh yeah, and that's what I'm going to show right now. So in this case, you could add as many test vectors as you want. And now what we're going to do is we're going to create a new test case where we're actually going to assign, instead of a single value, we're going to assign a test vector. So you right-click. Let me see if I'm still on the first one. Let me go to the one where I select the test vector. So the way you assign the test vector is by right-clicking on the input. So there we are. I don't care about the error in. I don't care about the class. I care about the string. So I'm going to right-click, and I'm going to select assign test vector. So because I already defined the test vectors in the other section, now they appear on my drop-down box. And now I can say, I want you to run all these sequence of numbers for this input. And the output has to have all these other sequence of numbers. So I'm going to right-click, select, assign test vector, and I can give the test vector. And if you guys want to explore this more, if you had the multiple inputs, you can change the index, and that's how you get all the possible options, which is what is reported down here. Because it shows the input permutations. Because I had a one-to-one relationship, it didn't show it. But if I had two inputs, I would have shown the different combinations that I'm capable of getting here. Does that answer your question, Steen?
It does. It really does. But has that functionality always been there?
Yes. The test vectors have, I think they have been there even before 2012.
I have tried the test vectors, but could only get it to do the permutations, not the one-to-one.
Oh, so the way you do that is when let me go back and do the rewind so you can see the menu. When I did the right-click to select which vector to use, okay, I broke it. When you do the right-click to select the vector, it has an option that says which index you want.
Yes.
And then you can select there to assign it a different index. When you assign it, both of them have the same index, then it's a one-to-one relationship. When you when you have different index, which is the default, then you have all possible permutations.
Okay, exactly, which often makes everything fail because...
Yes, and it is, again, it goes back to the path of discovery. I feel it's a very powerful tool. It is well documented, but you have to go read. It's not one thing where I can just go play with it and figure out how it works.
Real cool. I have to look at it again. Thanks.
Yeah. Any other questions? No? Okay. So then obviously the one for JKI, as you probably guessed, is just you put a for loop and you compare all your cases. Now, the thing with the VI tester is if you want to do all the possible permutations, that means you also have to do all the code for all the possible permutations. Okay? All right. So, okay, this goes to your question about automating running your tests at a certain time. Both tools have an API. The unit test framework has an API that lets you run all the tests from a project or all the tests from a file. The VI tester has the same thing. The VI tester also has a type of class that is called a test suite, where you can run multiple individual tests. And you can decide based on the list of the name of the classes which test you're going to run. The unit test framework has a priority per test. So you can tell it, I just want to run priority 1, or I want to run priority 1 and 2, etc. So, going back to my earlier slide, now if changing B causes A to fail, you will know. The whole idea for this is, I'm not telling you go back now and start doing test-driven development right away. It's probably going to be hard. But the next time you find yourself typing more than one value in your input to figure out if your output is correct, go and create a unit test. It takes you probably 20 more minutes. Yes, if you're time and materials or if you're fixed price, it feels like you're losing time, but you're going to feel much better at the end of the week when you have a test suite of 10, 15 BIs that you can run that tell you that all the work you did that week is tested. Yes, your tests are not going to be perfect. You're going to miss cases. You're also going to have the situation, which I've had, where you're on a code review or in a review and somebody says, but it passes the unit test, right? And I use that as an answer of saying we don't have a problem. Well, now we need to evaluate if the unit test is testing all the cases. So it just adds a little bit more to the conversation. So what about connections and peripherals or state data like Gabi was saying? That's considered integration testing. You can use the setup and tear down in those cases to set up your communication, both with the VI tester or with the unit test framework. Of course, if you're using Testen, you're already covered for that. So choose a unit test tool since the beginning and create tests every time you find yourself testing individual values. Go ahead.
I guess one question on the connections. I guess one of the things that's usually hardest with the hardware, which is kind of at the bottom.
Yeah.
And so what's the strategy there?
So the way I structure projects when I get to manage, most of the time I'm a consultant and I'm a fly on the wall and I can teach and preach what I want people to do, but then I just get to come back a month later and do a code review and tell them how bad they did. It's really not that often that I actually get to manage. But when I get to manage a team of developers, the way I structure the code is to do a module for each section. So you would have a separate module that just communicates with the hardware and has unit tests. When you move to the higher levels, you're no longer testing that. You trust that that works, and now you're doing unit tests for different sections.
So then
and
you
I
have
need
a simulation module for the
yes.
hardware, so that
yeah. So then at that point, I do simulation exactly. So when a bug is found, if it could have been caught by unit test, go back and create a unit test. If a bug is found that was not found by your unit test, go back and strengthen it. So don't go and create vectors for every test, right? Maybe you just know these might come back and haunt me. I'll just do the template with the 3-4 corner cases that I know, and later, at least you will have already the placeholder to come and add the test vector. It is better and more efficient to plan and do unit tests since the beginning, as opposed to going back. Like I said, that's what my next project is going to be, and it's not going to be fun, right? Because now I have to go through code that is already written, that probably already has pop-up dialogues in it, that's going to need to be refactored, because we need to comply with the checkbox. So, make unit test part of your process. Our goal is working software with minimum number of bugs, adapt to changing requirements without breaking existing code, identify what code breaks when we change requirements, and unit testing will get us there. Do it because it helps, not just because it's part of the process. If you want to learn more, Managing Software Engineering LabVIEW course, Eli has a wonderful large app software engineering technical manual and exercises for LabVIEW that has some good introduction to unit test framework. James McNally from the UK also has a really cool blog, and he had a really nice article about testable code in LabVIEW. And that's just thank you for the people that helped me prepare this. So, any questions? We don't have time, so I guess if you have questions, board. Thank you.